All right, so everybody close your Chromebooks. We're going to go through just a very, very quick little lecture, and then you can start this out.
It's not quick. I know it's not quick.
Okay, I'm going to take a page out of Mr. Sell's book, and if you fall asleep during lecture now, I'm going to have to ask you to stand up. So if you feel yourself falling asleep, maybe you stand up on your own. I won't have to wake you up with my trusty air horn. It's actually louder than it seems.
Oh my god. Yeah, let's not do that.
That just makes me want to act like I'm sleeping.
Yeah.
Maybe I'll do it real loud in the Chromebook to wake the people at home up. So look, this is not going to take very long. We have a short assignment on absolute dating, which is using the radioactive isotopes to conduct radiometric dating and figure out an age for rock. So we went through this a little bit Friday. We did the exploration Friday. I just want to show you some of the points that they talk about in the assignment. So they're going to ask you, there's only 2 questions, but as you remember, close your Chromebook. Terry, close your Chromebook. Yeah, thank you. All right. There's only 2 questions, but as you remember, they ask a lot of questions for each different one. So it's probably more like 6, 8 questions, something like that. But still not too bad. They're going to ask you about half-life. What is the definition for half-life, which we get to very quickly here. So I don't know that this first part is, but they ask you about the definition for isotopes. So you'll find that in the isotope section. Just read through it a little bit, figure out what you think the definition is, and type it in there. They ask you about parent and daughter isotopes, what the difference is between parent and daughter isotopes. That's going to be down here in the radioactive decay part. And so you should be able to find that pretty easily. And also, if you're not familiar with it, use the search function in Chrome. I think you click on the 3 little dots up here. Mine's going to be different because I'm not using Chrome. Click on the 3 little dots, go to find with the little magnifying glass, and you can type in whatever word you're looking for. It'll find it on the page. So if you don't want to have to read through everything, or if reading through long paragraphs is not your thing, use the find, and you can just read the part that you need to read. That'll help you out a little bit. So this part has the parent and the daughter isotopes. It tells you about that. Let's see what's next. They ask you about half-life, like I mentioned. So this will give you the definition for half-life and help you answer that part of the question. And then finally, they ask you, how does the parent-daughter isotope, how does that tell them about the age of the rock? And so that's going to be down here just underneath the math problem. They have this last little section, radiometric dating, and this last paragraph here kind of describes how they use the ratio between how much parent isotope is left over and how much daughter isotope is left over to figure out what the age is, how many half-lives it's undergone, and tell you what the age is. At the bottom, the second question, I think, asks about different radioactive elements and their half-lives, what's older, what's shorter. So their example is they have the half-life of lead, which lead-203 is only 12 days. So if I have like a big block of lead-203, in 12 days, half of it will turn into something else, probably a different type of lead. But half of it will have radioactively decayed, which is pretty short. 12 days is a short time. Carbon-14, which is still very short, is 5,730 years is a half-life. So you can really only get up to like 30, 50,000 years using carbon-14. If you use uranium-238, it's like 4.5 billion years. Just to show you some of the really, really short ones, I looked up, I Googled shortest half-life, and it gave me this list. And the very shortest one is hydrogen-7, which is only 23, yoctoseconds, which is so small, I've never even heard the name yoctoseconds before. Sounds pretty crazy, but it's 10 to the negative 24th second. So very, 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 very small. So yeah, there's yoctoseconds and zeptoseconds. And really, really weird, strange names. Attoseconds. If we get to something small that y'all are familiar with, like nanoseconds or microseconds, these elements decay. Half of it's gone in like less than 10 nanoseconds. Half of it's already decayed into something else. And so some of these elements only exist for literally a fraction of a second. Like we'll never be able to like have a sample and put it under a microscope and look at it. It just instantly just disappears into something else. They're very, very, very unstable. Those obviously won't be any use for absolute dating techniques. We need it to hang around for at least a little bit. But it is interesting to know about that stuff. So that should help you answer all the questions. The last part is just like, how do they pick which elements, or why do you pick different elements to do different things? Because you want to date things that are different ages. If you're trying to date something that's very young, like a human skeleton or a log that a human cut down to build a house, you're going to want to use the carbon-14 because it doesn't last for very long. It's going to be more accurate. If you're trying to date like an asteroid that may have formed at the very beginning of when the solar system formed, you want to use uranium-238 because it's about that age for one half-life. You should be able to accurately gauge its true age instead of having all of your carbon-14 just gone. And probably doesn't even have carbon-14 to begin with. So you should be able to answer all the questions. I assigned the reading. So if you go into the reading, you'll be able to see all these sections and stuff. I do wish that y'all could see my highlighted stuff, but you can't. You'll have to highlight your own or find it in the section. But use the book to help you answer the questions. There's 2 questions. Go ahead and get started. If you have any questions for me, please let me know. Or Mr. Yang at home, the last online student, you're welcome to come back whenever you want. We will all welcome you back with open arms. And if you have any questions, email me, and I will get back to you.